Okay, we're going to start today by reviewing the question that we started yesterday, last day, and we're looking at example 3 about the spring. So let's just reset the scenario. So remember, the string is hanging from the ceiling. We consider that the 0 case, and then we're going to pull down 60 centimeters and let go. And in this frictionless world, it's going to bounce up to 60 and then come back down to 60 and then back up to 60 and continue on. We were able then to say the amplitude was 60. It is a period of 2, and the reason it was a period of 2 is because it went through 10 cycles in 20 seconds. So that means it must have been 2 seconds per cycle. Since the period was 2, we could work backwards along here to figure out the k value was pi. And looking at the graph, this red graph, we see how it begins at 0, 0, just like the original sine curve. So there's no phase shift and no vertical translation. The only part is that it is flipped. So we had to put a negative 60 sine pi t. So that's where we left off now. Now we're going to go off and answer the third question, which is, when is the spring down to 45 centimeters? So the first thing we have to recognize is that down 45 centimeters means 45 centimeters below its resting point. So we're going to know that that's what I'm referring to as negative 40 centimeters. If we go back and look at our picture, down 40 centimeters would be someplace there. Okay, so we know that we have our equation, our original equation, which we just figured out, I guess last day, is negative 60 sine pi t. And what we have is, oh, sorry, not negative 40, negative 45. So we have c is negative 40, or y is negative 45. So we're going to go negative 45 equals negative 60 sine pi t. So we got to isolate for t. So obviously the first thing we're going to do is divide both sides by negative 60. That'll get us with a positive 0.75 over here, because a negative divided by a negative, sine pi t. I mean, technically we should see that pi t is in brackets. It's the sine of pi times t. All right. If in order to isolate this pi t, we're going to have to do the sine inverse. Of course, that will eliminate that sign. Remember that we are in radians on your calculator. So it's probably already set there from yesterday, but make sure it is there again today. So we're going to push a second function sine and go at 0.848 dot 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 equals pi t. And then of course divide both sides by pi to isolate for t. And we'll get 0.27 equals t. So we know then it is down to 45 centimeters below the equilibrium, or negative 45, at 0.27 seconds. So if I go back to my picture, it kind of makes sense. It happens relatively quickly. Negative 45 is someplace around here. And boom, there it is. Remember, this whole thing is 2 seconds. So this is 1 second. So there's the spot right there. But of course, by me drawing it, my question is there only one time that it is down to 45 seconds? We can see the first time is right here. But we can also see that it happens again. And then, of course, it is going to happen again, and again, and again, and again, and again, and again. But the question I have now is, when's the second time that it's at down to 45? So for that, we're going to really consider this graph. So I'm going to redraw the graph right here so I can talk about it. I'm going to be a little more detailed here than before. And I'm just going to go down like this, up, and down. We know that one cycle happens in 2 seconds. So this is 0. This is 2 seconds. This is one cycle. So obviously halfway it's at 1 second. We also know that it goes up or down to -60 and up to +60. And the spot I'm interested in is this spot here. This is -45 or 45 centimeters down. So we just did all this math and we found out that the first time it happens is at 0.27 seconds. So right here is the first spot. So this spot right here, from here to here, is 0.27 seconds. What I'm curious about is where this spot is. So how long will it take to get to that spot the second time it hits -45? Well, the good part about this is we understand that the sine curve has lots of symmetry. So we're going to take advantage of the symmetric properties of the sine curve to figure out where this spot is. Sorry. So where is this spot on the graph? Well, since this part of the graph goes 0.27 this way, then over here, this must be 0.27 as well. That's the idea of the symmetric properties of the sine curve. It goes down the same way as it comes up, and vice versa, it goes up the same way it comes down. So although my sketch is not bad, it's not perfectly the same, we should know that this much and this much should be the same. So if this much is 0.27 seconds, it's 0.27 seconds away from 1. So we can figure out that this one must be 1 minus 0.27 seconds, or 0.73. So now I can be a little bit more specific and say it is at -45 at, well, the first one, 0.27 seconds. Then the next one at 0.73. And then when's the next one going to happen? Well, the next one's going to happen way over here, isn't it? It's going to happen here. Well, again, it's going to be 0.27 seconds, but this time it's going to be from 2. So I know that that is obviously 2.27 seconds. And the next one would be 2.73, and so forth. And the next one would be 4.27 and 4.73. So if I were to ask you when is the spring down 45 centimeters or at -45, I'd have to be a little bit more specific. I'd have to say, hey, when's the first time? Or tell me the first 2 times that it's there. And that'll be appropriate for the questions we're going to do today. Okay,